So let me start with an example to discuss limits at infinity and horizontal asymptote. So look at this function x plus 1 over x plus 2. And this table shows the function values of f as x gets larger and larger and as x gets smaller and smaller. So as you see in the table, the function value f gets very close to 1. So those values are getting closer to 1, and those values are very close to 1 as well. So from this table, we can say we can talk about the behavior of this function as x tends to infinity or negative infinity. So basically, when you take the limit of f as x tends to infinity, the limit is 1. Even when your x gets smaller and smaller, the function value are getting closer to 1. Actually, if you look at the graph of the function, so here is the graph of function, and you see there is a horizontal line which is y equals 1, to which the graph is getting closer and closer as x tends to infinity. And as x tends to negative infinity, your graph is getting closer to this horizontal line y equals 1. So that gives us some example of limits at infinity and horizontal asymptote. So this special line y equals 1 is called horizontal asymptote because this line, horizontal line, gets closer to the graph as x tends to infinity or x tends to negative infinity. So using this example, let us define limits at infinity. Okay, here is the definition of limits at infinity. So look at those graphs. So as x, in the first graph, as x tends to infinity, our graph is getting closer to this horizontal line. Similarly, as our x tends to negative infinity, our graph is getting closer to this straight line. So in this case, we have only one horizontal asymptote, but sometimes your function may have two horizontal asymptote. So first horizontal asymptote as x tends to infinity, and the other horizontal asymptote when as your x tends to negative infinity. So geometrically, this is what will happen when we talk about limits at infinity. So we say limit of f as x tends to infinity L if the function values are getting closer to certain finite value, say L, then we say the limit of f as x tends to infinity is L. Similarly, when your x tends to negative infinity, suppose your function values are getting closer to certain value L, then we say the limit of f as x tends to negative infinity is L. So those horizontal lines are called horizontal asymptote. So this line, y equals L, and then those lines say y equals L1, y equals L2, those horizontal lines, those are called horizontal asymptote. When the limit happens to be L, when your x tends to infinity or your x tends to negative infinity.